So good evening, everyone, and welcome to this class. So we are going to start with X-rays, and we will try to wind this chapter up in one or maybe two classes. Not in one class, but in two class. Now, what are the things that you must remember about this X-rays? Have you heard this term X-ray? Yes or no? Yes, you
Good
must have
evening,
heard
sir.
this. And if you are planning to become doctors, this is what you must be dealing with X-rays. So everything based on this chapter would be information based. So you just
Sir,
yes, beta.
sir, am I audible, sir?
Yes,
Sir,
audible.
good evening, sir.
Good evening. Good evening. What happened? Everything is okay.
Yes, sir.
Okay. So this X-rays. Remember whatever points are there. Remember about them. This X-ray. So what has happened here is something wrong. Okay. These X-rays were discovered by a scientist named Rohinton. Remember this? They might straight away ask you who discovered X-rays, so you must be able to remember. The wavelength of X-rays is in between zero point 0.1 to 10 Armstrong unit. This is specifically for you, for medical students. JEE you don't need this. These rays are invisible to eyes. They move with a speed of 3 into 10 raised to the power 8 meter per second. Do you understand this?
Yes, sir.
You just note down these points about X-rays. Discovered by Rohinton, what is the wavelength? Electromagnetic waves, they move with the speed of light. I will give you more properties of X-rays because these are the properties of X-rays that will come. But first, let us do the other things. Let me tell you the properties first, then you can note down the properties first so that those theoretical based questions are taken care of. Where is those properties? I had that properties. The list of those properties is not here. Must be here in this one. You can note down these properties first. Okay, it will be here. Properties of X-rays. Have you noted down these three properties?
Yes, sir.
Okay, these are the list of properties. I think first property you have already written down, wavelength 0.1 to 100 or 10 Armstrong units. The wavelength of X-rays is very small compared to the wavelength of light. Therefore, they can carry much more energy. X-rays are invisible. They travel in a straight line with the speed of light. The unit of measuring X-rays is in Roentgen. They measure its ionizing power. All these are information-based question, beta, specifically for NEET. They carry no charge, so they are not deflected by electric or magnetic fields. They are not deflected by an electric or magnetic field. Do you understand this? You will
Yes,
have to
sir.
just note down these properties as they come. Most of the question that we face are based on these properties. You can see these properties, yes or no?
Yes, sir.
Okay. Keep noting them down. Okay. The next property is with regard to the wavelength of these X-rays, and this question has come many times in your NEET. This wavelength of X-rays lies between gamma rays and UV rays. So in the electromagnetic spectrum, they lie somewhere between gamma and UV rays. They are used in the study of crystal structure. Again, one information-based question. They ionize the gas through which they pass. X-rays do not pass through heavy metals and bones. That's why you can see the X-ray. They cannot pass through bones. They can pass through the skin, but not through bones. They affect photographic plates, and that is why you see your X-ray on the photographic plate. Long exposure to X-rays is impossible. That is why if you ever open this lab for X-rays, most of the MBBS doctors and MD doctors, they do open their own labs for conducting these X-rays. They are subjected to these X-rays, which is obviously not good for us. Do we understand this?
Yes, sir.
I hope everyone is noting it down.
Yes, sir.
Okay, have you noted down this one?
For 1 minute.
Okay, I'll give you time. Noted down, beta?
Done, sir.
Okay. Then you move on to the next properties.
Sir, can you please wait for a minute?
Okay. I got scared. Everything is okay? Have you noted it down, bacha, now? Waiting. Abhiram has done. Abhiram, let's wait for others to do. Have you noted down till point number 12?
Yes, sir.
Other class? What is happening? Okay, we move on to the next point. Lead is the best absorber of X-rays. We know this. For X-ray photography of human body, this is very important to us. Barium sulfate is the best absorber. They produce photoelectric effect and Compton effect. X-rays are not emitted by hydrogen atom. They cannot be used in radar because they are not reflected back by the target. These are all information based questions, and you will have to just note them down and remember them. I'll give you 5 minutes to do this. Let me know once you are done, bacha.
Done, sir.
The other class, I can't.
Done, sir.
Okay. Now remember, all these things are basically based on points, and you must remember these points. How you are going to remember this? Well, you are supposed to know this. Now, the last point here is this. I will just write it down. See, these are electromagnetic radiations. X-rays are electromagnetic radiations. So the last point is they will show all the properties: light, reflection, refraction, interference, diffraction. They will show all properties like this because they are nothing but electromagnetic radiations. Do we understand this? So
Yes, sir.
they will show all of these properties. That is what you must remember. Give you 2 minutes to do this. Once you done, please let me know.
Sir.
Okay. Now we'll have to understand what or how X-rays are produced. Any idea how or why? How do we produce X-rays? How can we produce X-rays or how X-rays are produced? Any idea about that? No? So they shoot electrons in our body. Your body does not produce X-ray, beta. Does your body produce X-rays? No, na? Your body does not produce X-ray. Then how are X-rays produced? How are X-rays produced? Your body does not produce X-rays. Then how are X-rays produced? Anyone can give me any insight on this? No one? Well, so write this. I hope you can see my screen. Okay. When fast moving electrons hit a metal of when fast moving electrons hit a metal of high atomic weight, then your X-rays are produced. When fast moving electrons, highly energetic electrons which have large kinetic energy, when they strike a metal plate which has got a high atomic weight, then you have X-rays getting produced. Now, having said that, what are the things that you need? What are the basic requirements that you must have, basic equipments that you must have to produce X-rays? What are things we should have to produce an X-rays? An X-ray. Tell me. Hmm? There are three things that you need to produce an X-ray. There are three things that you need to produce an X-ray. What are those three things? Number one, you need a source of electrons. You should have fast moving electrons, so you must have a source of electron that gives you must have a source that gives you these electrons. Do we understand this? That is the first
sir.
requirement that you need to produce an X-ray. You need a source of electrons. Then, what is the next thing that you need? Someone to accelerate. You need something to accelerate these electrons. And then you need a metal of high atomic weight. Then you need a metal of high atomic weight, which can be used as your target metal, which is going to eventually produce your what? Your X-rays. Do we understand this? We got this.
Yes, sir.
Now, where are these X-rays produced? It's produced in a device, in a tube, in a chamber. What is this known as? Any idea? Is produced in a device known as a Coolidge tube. What is it known as? A Coolidge tube. So write the next heading, a Coolidge tube. Coolidge tube. This is a place where you produce an X-rays. And how does a Coolidge tube look like? I have got a diagram, and you draw it as good as you can, and then we will study the various elements of this diagram. I will mark out the important elements of this diagram first. The first element is known as filament. Do you see this filament, my dear friends?
Yes, sir.
That is the first element that you must remember. Now, this filament is nothing but a heater. Do you see this heating coil? So it has a current I flowing into it. This is the first element that you must remember in this. The second element that you must remember here is this voltage source. Voltage source. This filament is actually connected to the negative terminal, so it becomes cathode. Then the third element here is this T target, which is connected to the positive terminal, and that becomes your anode. That is your target. These are the three elements. Apart from that, I will explain each and everything in the diagram. First, draw this diagram. Why I've mentioned these three elements? Because these three elements are the three things that you require. That you require to do what? To produce X-rays. This is number one. This is number two. And this is number three. Give you 2 minutes to note this down. Draw this diagram. Aram se entire X-ray is based on this diagram, and you will hardly get any question, numerical question on X-ray. You will only get a theoretical question on X-ray.
Done, sir.
What about the other class? Are we there? Huh?
Done, sir.
Done, sir. Okay. You mark these three elements. We have seen what we need to produce X-rays. Now let us note point by point their importance and what they are doing in this Coolidge tube. So let us now note them. The first element in this thing is the filament. So write the heading filament. Filament. What is the job of this filament? What is the job of this filament? This is the source of electrons. It is heated. This filament is nothing but a sort of heater. It is heated by electric current. The electric current I that we draw in the diagram. Did we draw this current? Yes or no? It emits electron by the phenomena of thermionic emission. Now, what do you mean by this thermionic emission? I told you about this photoelectric effect. What happens in photoelectric effect? These metals have electrons which are bound to the nucleus. If they get sufficient energy, they can leave the parent atom and wander freely. Now, one way to giving them energy is by allowing light to fall on them. That is photoelectric effect. The other way to give them energy, and I told you that is by heating the metal. Yes or no? So if we heat the metal, if we heat certain metals, the electrons can get sufficient energy and they can move free. That is known as thermionic emission. Do we understand this?
Yes, sir.
Thermionic emission. So this thermionic emission is by heating. This is the work of the filament. Now, if the current in the filament is increased, current in the filament is increased, then what happens? If the current in the filament is increased, then what will happen? More heating? Yes or no? More heating of the filament. Because of more heating, what will happen? More electrons will be emitted. Because of more electrons emitted, what will happen? More electrons will strike the target metal. Yes or no?
Yes, sir.
Therefore, we will have more X-rays, more number of X-rays. That means when you talk about the number of X-rays, you talk about the intensity of X-rays. We saw in the last chapter when we were talking about intensity, we talked about the number of photons or the number of radiations that are falling. Do we understand this? Yes or no?
Yes, sir.
So that means if the current I is increased, the number of electrons are increased. That implies number of X-rays are increased. That implies the intensity of X-rays is increased. That means the intensity of X-rays is directly proportional to the current I in the filament. Do we understand this? Yes or no? No, yes.
Yes, sir.
I'll give you 2 minutes to note this down.
sir.
Yes, bacha.
Done, sir.
Sir.
Done, everyone? Shall we move ahead?
Yes, sir.
Okay. The second thing was in green. That was the voltage source. What is the function of this voltage source? It is to create a potential difference between F means filament and T means target. Between filament and target, your filament is negative or cathode, your target is positive or anode. Do we understand this? Yes or no?
Yes, sir.
You can also see it in this. I hope everyone can see this graph. This green, oops, wrong color. This green battery is the voltage source. It creates a potential difference between your cathode and your anode. We understand this?
Yes, sir.
Now, electrons, wrong color still. Electrons are emitted by this filament and they are going to strike the target metal. As soon as they strike the target metal, these are the X-rays that are coming out. Everyone sees this?
Yes, sir.
Now, if you change the potential difference between the cathode and the anode, what will happen? If you increase the potential difference between cathode and the anode, if the potential difference between the cathode and anode is increased, then what will happen? That will imply more kinetic energy of electrons. Yes or no? That means more energetic electrons will strike. More energetic electrons will strike. That means more energy X-rays will come out. Do we understand this? So if the potential difference PD or potential difference V is increased, the energy of electrons, energy or kinetic energy of electrons increase. That implies the energy of X-rays. The energy of X-rays increase. That implies the frequency of X-rays increase. Frequency. You understand frequency? Yes or no?
Yes, sir.
Please note this down.
Done, sir.
Everyone got this? Shall I wait?
Done, sir.
Okay. That takes us to the third thing. And the third thing is your target. Third thing is your target. Now this target produces X-rays. Do we understand this?
Yes, sir.
This is a metal of high atomic weight. We have already seen that. Yes or no?
Yes, sir.
Now, apart from this, there must be certain characteristics of this. So I'll show it to you and then you can note them down. All these are information based questions and you must be able to remember them. So what is the characteristics of the target? First listen to me, then you can note it down. The first characteristic is it must have high atomic number to produce hard X-rays. The atomic number is not high, it will not produce high energy X-rays. It must have high melting point to withstand the high temperature produced. When these electrons hit the target, the temperature rises because the metal absorbs a lot of energy. The temperature rises. If the metal is not having a high melting point, the metal will melt and we don't want this. It must have high thermal conductivity to remit the heat produced. Lot of heat would be produced. It must have high conductivity so that you can remove that heat. What are the metals used? You must remember the names. Okay, I'll give you 1 minute to note this down. Have you noted it down, bacha? Okay. Now,
Sir,
yes, bacha?
sir, 1 minute.
Okay.
Done, sir.
Okay. Now, in the diagram, you see, bacha, there are two things that we did not discuss. We have discussed point number 1, filament and the current in the filament. Yes or no? We have discussed point number 2, the green potential difference. We have discussed point number 3, the T target, high metal, metal of high atomic mass, atomic weight. The fourth point, if you can see here, is this lead chamber. Why is this lead chamber? Lead is a good absorber of radiation. These radiations are very harmful, so if they get out, is going to be a problem. So it absorbs all these harmful X-rays and only allows X-rays to come out from this point. The fifth one here is this water. Why is this water here? Why is this water here? Anyone? Why is this water here? I can see students drinking water, but why is this water here?
Control the electron.
To control? It is to cool down this target. To cool down the target. Actually, this target is covered by this casing is actually made up of copper. Copper is a good conductor, so it conducts heat quickly out, and this copper chamber is heated by this water. So that is why this water is here. So now we have covered all the aspects of this Coolidge tube. Do we understand this? Yes or no? Huh?
Yes, sir.
Now, whenever we talk about X-rays, there are two things that we always talk about, and we'll quickly go through this. Whenever we talk about X-rays, we talk about two things. The first thing is the intensity of X-rays. Now, when I say intensity of X-rays, what do you mean by intensity of X-rays? This intensity of X-rays means the number of X-rays. Do we understand this?
Yes, sir.
Who controls this number of X-rays? This number of X-rays or intensity is directly proportional to the current in the filament. Do we understand this? Yes or no?
Yes, sir.
The second thing that we are concerned about X-rays is the energy of X-rays. Instead of calling it energy, you can call it the penetrating power of X-rays. You can also call it the frequency of X-rays. You can also call it the quality of X-rays. Both of them, all of them mean the same thing. Now, by this energy of X-rays, what do you mean? How energetic they are. Do you understand this? Energy or penetrating power. Who controls this energy or penetrating power? This energy or penetrating power or frequency is directly proportional to V, the potential difference between the cathode and the anode. Do we understand this? Yes or no?
Yes, sir.
Now, basis of this, wrong color. Now, based on this quality or the frequency or the penetrating power or the energy, X-rays can be divided into two categories. One is known as the hard X-ray, the other one is known as the soft X-ray. One type of X-ray is known as hard X-ray, the other type of X-ray is known as soft X-ray. Do we understand this? Yes or no? Have we
Yes,
noted
sir.
it down, bacha? Have we noted it down?
Sir.
Yes or no? Then you just need to note this down and that will end the class. What is hard X-ray? What is soft X-ray? Hard X-ray, hard, they're hard. That means they have more penetrating power, more frequency and less wavelength. Soft X-ray, less penetrating power, less frequency and more wavelength. I'll give you 2 minutes to note this down. Have you noted it down? Yes or no, bacha?
Done, sir.
Everyone done, sir?
Sir.
Well then, that brings us to an end of this class where we have seen how X-rays are produced, and we have seen the three important elements in X-ray production: the source of electron, the potential difference which accelerates the electron, and the target metal. In the next class, we will do some questions and also see the types of X-rays based on how these X-rays are produced. So we'll see that in the next class. I'll wind off the class here. See you tomorrow. Tomorrow means Monday, and we will continue with this lecture. So take care, beta. If you have any doubt, you can always come up and ask me. Bye bye.
Sir.
Have a nice day. Yes, beta.
So for tomorrow's exam, which chapters do we have?
Well, for tomorrow's exam, you will have ray optics, wave optics, thermometry, thermal expansion, and your photoelectric effect. X-rays is not there. Okay.
Okay, sir.
Bye bye. Take care. God bless you.